Hello and welcome to this pre-recorded event for AS Product Design, Graphic Products. To help you get the most out of this feedback, you may want to have these following documents handy, as we will refer to them during the session. We will look at the three aspects of the AS coursework during this presentation and highlight successful and less successful approaches to the presentation of this work. Just to remind you of the requirements in the 6 GOR1 course. Students must produce a portfolio of creative skills, which is divided into 3 discernible sections: product investigation, product design, and product manufacture. In the product investigation section, students must select a product that contains at least 2 materials and is manufactured using more than one process. They are required to investigate the selected product under the headings Performance Analysis, Materials and Components, Manufacture, and Quality. Students, under teacher guidance, have complete choice in selecting appropriate products for investigation. The work can be presented in either A3 or A4 format. In performance analysis, students are required to justify how the specification has been met for the product under investigation using the following headings. Form. Why is the product shaped or styled as it is? Function. What is the purpose of the product? User requirements. What qualities make the product attractive to potential users? Performance requirements. What are the technical considerations that must be achieved within the product? Material and component requirements. What are the requirements of the material properties in the product performance? Scale of production and cost. How does the design allow for scale of production, and what are the considerations in determining cost? When analysing a product under these headings, students should justify statements to say why they are important to the product. They should also say how these needs have been achieved. Students can investigate any product of their choosing as long as it consists of a minimum of 2 materials and has been made using more than a single process. As well as justifying the specification for the selected product, students must identify a similar product and compare and contrast the two using the specification headings described previously. In order to compare and contrast effectively, students must identify differences in the 2 products in order to discuss relative design features and determine which meets a specification point best. It is therefore important that the similar product is not too similar. Where products are too similar in form, function, user requirements, performance requirements, materials, etc., there are fewer opportunities to identify differences and compare and contrast. The product pairings shown here are so closely related that no effective comparisons can be made. The products shown on this slide are similar, in that they fulfill similar needs, but they differ in the way these needs are achieved. Lots of opportunity to compare and contrast under the specification headings is offered. Here, we are treated to a significant amount of information. The work is a detailed investigation into one product, and then a comparison is made with another using the technical specification. Initially, the detailed input is quite good, although many statements are sadly unjustified. Comparisons have been made to a product that actually has differences to compare with. The comments connect to the product but fail to be justified fully. However, there are some connections, so 6 marks were awarded. Here is an excellent example of 2 different products that are too similar to allow for an effective comparison. You will note a great deal of both games have, both games are, type comments. This inability to effectively compare or contrast products prevents candidates from demonstrating as much knowledge as would be demonstrated by those comparing substantially different products. Obviously, games provide a great deal of opportunities to allow in-depth manufacturing and materials property knowledge to be demonstrated, as there are a number of component parts within each game. Unfortunately, the packaging, games boards, and component parts all utilize similar manufacturing processes and materials, hence restricting opportunities for contrast and comparison. In the next part of product investigation, materials and components, students are required to identify the materials and/or components used in the making of the product under investigation. Only the original product, and not the similar one, must be considered in this section and the sections that follow. The similar product is only appropriate to performance analysis. Because products will vary in the variety of materials and components used, it would be unfair to ask some students to investigate all the materials used in a complex product, such as a computer game controller, whilst others looked at the materials used in a bean container or a perfume bottle, where the minimum requirements of 2 materials is met. Taking this into consideration, students are encouraged to identify only 2 or 3 materials or components used in their selected product and to investigate these. When identifying properties, this task is mistakenly seen by many students as an opportunity to list everything they know about a material without any selectivity or justification for use. A moderator does not want to know that a material is a good electrical insulator when it is being used for an underwater application, or that mild steel contains less than 0.3% carbon without some reason for presenting this information. When material properties are given, it should be justified as to why they are important to the design needs of the product, and not be part of generic information that could apply to any product. Having identified 2 materials and discussed advantages and disadvantages, students are required to suggest one appropriate alternative for each of those materials. Unfortunately, many alternatives given are almost identical to the original material, especially where plastics are concerned, such as ABS and HIPS, or PVC and polypropylene. Part of the reasoning behind this section is to encourage students to use their knowledge and understanding of a wide range of materials when applied to products, giving relevancy to their Unit 2 studies and hopefully creating more interest. As part of this section, students should consider the environmental impact of extracting and processing the raw materials used in the product and their disposal. Often, responses are limited to recycling and generic statements regarding air pollution, where more detail is required. The work submitted here is detailed and informative. The candidate intelligently informs us about the reasons for choosing the materials and makes some sensible suggestions for alternative materials. The work has many qualities of a higher level, including the discussion of detailed sustainability issues. The work is discussed in terms of advantages and disadvantages, but the comments are not specifically connected to the product. However, there are inherent connections in the justifications offered in the commentary, which allows us to then allocate 8 marks from a possible 9. The next task in this unit is to investigate the manufacture of the product by identifying and describing 2 commercial processes used and suggesting an appropriate alternative for one of the processes. When identifying processes, students should use advantages and disadvantages to justify their use in meeting the design and manufacturing needs of the product. Generic statements that could apply to many other products should be avoided. What, on the surface of it, looks like a thoroughly produced table on this slide has significant weaknesses when looked at in detail. Upon closer inspection, it can be seen that the candidate makes little sense at times, but also fails entirely to link the reasons for use of the manufacture process to the product being made. It could easily be generic information from a textbook. It is often difficult for students to suggest an appropriate alternative manufacturing process, especially where plastic moulding is concerned, which can result in inappropriate processes being suggested. where there is no real alternative to a process such as injection moulding, it is acceptable for students to suggest a process that would be appropriate if a different material were used, as long as they name the material. It should be borne in mind that any processes identified or suggested should be those used in commercial manufacture. Students should describe the environmental impact of using the manufacturing processes identified, which will be different to the effects described in the previous section relating to materials. The manufacturing methods are correctly listed on this slide, although the printing process selected could be argued as more likely to be flexography. The processes are not particularly well connected to the product in their justifications. Advantages and disadvantages have been clearly applied, but lack detailed connection to the product. Sustainability issues are raised in a superficial way. The comments are generic and lack focus. Sensible alternatives are, however, offered. It is unlikely that this submission will exceed any more credit than 7 out of 9 marks. It achieves 7 as the mid-assessment criteria has been exceeded. The final section in product investigation focuses on quality. To meet assessment requirements, students must describe a range of quality checks carried out during the manufacture of the product, specifying what checks would be, how they would be carried out, and utilising what equipment. A quality assurance system should be designed for the product, and this could take the form of a flowchart. For example, using headings such as preparation, processing, assembly, finishing, and after sales. Commonly, responses are submitted that describe what quality control and quality assurance are, but what is required is a range of realistic quality checks as described previously, and a quality assurance system focused on the product in hand. As part of this section, students should identify 2 or 3 relevant standards and explain how they would influence the maintenance of quality in the manufacture of the product. It is not enough to simply identify standards. Students must say how those standards relate specifically to the product and its manufacture. Here, a sound submission of quality assurance, QA, is offered, but not supported by the required quality control, QC, information. It relies too heavily on broad statements identifying checkpoints and does not explain the checks in any detail. The work is not as clearly laid out as it first appears to be. We have a QA system outlined and quality standards are explained clearly. The explanation of specific QC points, again, is not always evident, although some of the QA systems have QC exemplified within them. Hence, we need to adjust within the top range of marks. Comments are a bit light on how to check, but they are evident. A mark of 4 is the least one would expect here. In the product design section, students are required to submit at least one design task appropriate to AS levels of response that demonstrates their design competencies. They are encouraged to be as creative as possible, and, to support this, there is no requirement for the designed product to be manufactured, which means no constraints are placed on designs through the limitation of resources found in centres. Students have the option in product manufacture of making what they design or making something different. In the course of designing, students are expected to produce a range of initial design ideas accompanied by technical annotation, a review of design ideas based on product specification requirements, and develop designs into a final proposal that includes enough detail which would allow a skilled third party to manufacture the intended product. Students under teacher guidance have complete choice in selecting appropriate design briefs. More than a single design brief may be undertaken, depending on the skills a teacher wants to develop in their students. Most, however, pursue a single design task. Work should be presented in A3 format. The starting point for the product design exercise is to present some measurable design criteria. This is used as a guide and reference point as designing progresses and later in the evaluation process. Here, we see a selection of starting points. All of them are appropriate as no limits are placed on what should be designed. We have garden furniture, cosmetic packaging, and a games console controller. The latter two are more readily appropriate to graphic products, though this is not a problem for the submission. It could be argued that furniture design does not lend itself to supporting the additional parts of the specification as well as the other two briefs. What all three have in common, however, is a design brief given or developed by the student and a simple design specification which can be used as an evaluative tool during the process. The starting point for our example design product is a redesign on an existing brand of perfume bottle and box. The brief explains the needs of the assignment and then a specification is offered for later use. On this slide, we see a selection of design images for perfume bottles. The designer has utilized a variety of inputs for the generation of ideas and has attempted to illuminate how a number of subsystems could be made to work effectively and how they would affect the design outcome. Good use of technical terminology has been used, with some use of decision-making and review. The work is then formally evaluated against the specification for each design of the bottles. The work does not have great depth of change or design exploration. Technical aspects are covered, but bottles are obviously quite similar in manufacture process, so some restrictions would be expected. The work is, however, supported by the design for the box that the bottle will be contained within later. Hence, it is always useful to view this section holistically to ensure that a full picture is gained before the assessment is made. The bottle is developed along the lines of the individual subsystems in the lolly idea after the butterfly idea is discarded. Modelling is utilised and used to change ideas and move the whole concept forward. Review is included and decisions are recorded. This is not the only development work to be credited. We also have to consider the development of the box and its external graphics too. We have now returned to designing evidence. Here, the box graphics are considered and a variety of boxes are trialled. These are likely to be existing nets from a commercial source, but this is what might be expected from a commercial designer. The nets are trialled and then changes are incorporated to meet the requirements of the designed bottle. Obviously, the bottle ideas will need to be finalised before the box can be designed. There is excellent use of modelling here. It is not just a presentation tool or offered as a fait accompli, but has been used as a tool to check and evaluate the changes being recommended. Here, the net has been changed and the final shape of the box decided upon. The designer then develops the final style or presentation graphic to be applied to the outside of the box. This is a good opportunity to use CAD as part of the design process. Again, this should be used as a tool to trial changes, not just as a presentation device. Here we see a final design proposal presented with the detail required for manufacture. This detail can be for commercial or modelling purposes. What is required is the comprehensive nature of the detail to enable some form of manufacture to take place. The design work for the bottle and box, seen holistically, is varied, workable and has a good deal of detail. The development is particularly good, with extensive use of modelling and CAD to develop and resolve design changes. This is excellent work for this level, and there should be no doubt about a high assessment in this section. The communication of the work is crisp and well presented in places, the more formal work a little less so. The annotation is detailed and well communicated, but the information offered in the working drawings leaves little to the imagination in terms of sizes and the actual net to be used in the package. The marks in this section should be in the top assessment criterion, but towards the lower end at 10. It goes without saying that the design work here is detailed and varied. The candidate is making great efforts to explore all sorts of opportunities in the design of these perfume bottles. Here, the work is too fixed in single idea outcomes, with very few changes or detail to the subsystems. It should also be noted that the CAD work is not really reviewed or used to trial new ideas or changes, and the specification is not connected to the ideas being considered. Modelling is also used, but as a presentational tool, to trial the final design where no further changes were then offered after the modelling had taken place. In product manufacture, students are required to plan, make, and test one or more products that match the manufacturing criteria of the task. It is key for this part of the portfolio that a range of advanced processes and manufacturing skills are evidenced. This is usually evidenced through a range of products being made, although it may be possible to demonstrate a range of processes through one product if it is demanding enough and requires a range of processes. In this section of the portfolio, it is strongly recommended that teachers set the manufacturing tasks in order to ensure that students improve competencies and learn new skills in preparation for A2 tasks. It is a rule that where CAM is used, it must not exceed 50% of product manufacture. Where more than one product is made, planning and testing should only be evidenced once. It's a requirement that clear photographic evidence is submitted that shows the quality and complexity of challenge relating to all manufacturing tasks. This can be added in the portfolio as a manufacturing diary and preferably should be for all products made. Work in this section should be presented in A3 format. This Gantt chart has no specific timings. This is not an issue if the chart is to identify key deadlines, but the work has focused on the identification of the key folder deadlines and not the manufacturing aspects. This is largely of no merit. In this case, this Gantt chart shows information relating to the actual manufacture of the product in this case, which helps in providing evidence of key deadlines, but it does not contain enough information to form a detailed production plan. It should also be noted that the manufacturing processes rely a lot on the single manufacturing process, that being CAM outputs, and is not likely to represent a wide enough range of processes for marks at the highest level in this section alone. Here we see an example of a high-performing candidate in this section. The product is a model of an existing building. The candidate shows what is intended, provides a simple manufacturing specification for use in the evaluation section later, and justifies the manufacturing processes and the materials used in the model making. The candidate has offered a breakdown of the major deadlines and their approximate timings. This could be argued as being even a little too detailed, as it is only expected that the main component parts be detailed. This is a top submission in this part of the portfolio and would score highly. The manufacture of the architectural model has been well documented, as can be seen from the photographic record of its construction. The final product is adequately made but relies quite heavily on laser cutting. It is fortunate that the candidate also submitted the following model seen on the next slide. Here we can see the second product made by the candidate, a point-of-sale display for a perfume bottle. New packaging was also designed for the existing bottle. Clearly, with colour sublimation, sheet metal work, and graphic image manipulation, this candidate has enhanced the range of skills from the previous model that relied a little too heavily on laser cutting. The work is deemed to be a top quality response in this section, if not at the very top end. The final part of product manufacture is testing, and this should be done using measurable performance-related criteria that should have been set at the beginning of this section. Wherever possible, field trials should be used to test a product's fitness for purpose, and superficial testing should be avoided. Tests to see whether a product is aesthetically pleasing or includes particular named materials or techniques are not valid. Tests should be technical and rigorous. Tests should also be objective and described in terms of what was being tested, how the test was carried out, and what the results were. Where third-party testing is used, superficial, congratulatory statements should be avoided. The same performance criteria used by the student maker should be used in third-party testing to ensure objectivity. Testing of the second product is not required. Here, testing is offered and explained, but not justified. The testing is realistic and objectively considered. There is third-party evaluation, and the results of the tests appear to have been taken into account. It is a good performance, but only scores 5 out of 6, due to the lack of justification of the tests.